Hello guys, my name is Piers and today I want to talk about microservices, some of the negativity they get and the trend to go back to monoliths. So are microservices bad? Well, it depends. It's like asking a question, is buying a racing car bad? If you want it for day-to-day transportation inside the city, yes, it's bad. If you want to race in a racing track but you don't have the skills to race, yeah, it's bad. But if you are a race driver and you want that car so that you can race in a racing track, then it's a good buy. So what I think happened with microservices is that it was the new shiny thing and everybody went and implemented and or they didn't have a need for microservices or they implemented poorly. Let me show you what I mean. Let's say we had a monolith that was a monolith with 4 modules, module A, B, C and D, and we went and made 4 microservices, service A, service B, service D, C and service D. By the moment we did that, we had the complexity at the exact same time. Now we have to manage with 4 deployments instead of 1. Also, in one way or another, you have to transport some data between those services over the wire, and since it's over the wire, some of that transportation will fail and you have to deal with that too. Also, monitoring can become more tricky, so by the moment you separate a monolith to different services, you add that kind of complexity. And the answer is, do you need to add that complexity? I mean, do you have, for example, different teams working in each service? If yes, maybe it's a good idea to go to microservice because you want each team to plan, develop and deploy independently from each other. Also, do you have a module, let's say module B, having to do a lot more work than the other modules and needs more resources? If yeah, maybe that's again a good idea to turn to microservice because now you can scale service B independently from the others and save costs in the cloud because you only scale service B and not service A, C and D at the same time, like if you would do if you had a monolith. But if you have the same team working on all of these modules and you don't have the need to scale each module independently, if you at some point you have more traffic, all of these modules need to scale up, then probably you don't need to have microservices and modular monolith with good boundaries between those modules would be better because you would avoid all that complexity that we talked about. And that brings me to the second reason, which is bad design of microservices. Let's say we have a doctor's application that its goal is to bring together doctors and patients to schedule appointments online. So a doctor can add an office in which can examine patients, maybe has an office in one city and one in another one. Then a doctor adds a schedule with available hours in its office so that the patient can book an appointment, and then a patient books an appointment. So we have between others 2 services, the office management service and the appointment scheduling service. So the office management service is responsible for creating an office and the details about the office like the address, the floor if it's in a building, the accessibility, etc. And the appointment scheduling context, when I say context, bounded context or service, I mean the same thing. You can think the bounded context as the service. So in the appointment scheduling context, the office is an office that has a schedule which patient can book appointments, doesn't have the concept of an address and floor, etc. They are two different things in different contexts. So the office lives in both of these contexts but means different things to each one of them. Now let's say that a doctor wants to delete an office, so it will do it in the office management context, but when an office is deleted we don't have to have a schedule, so patients can book appointments in an office that no longer exists. So maybe you say, okay, I will delete the office in the office management service, and then I will make an HTTP request to delete it in the appointment scheduling service as well. But what happens if that second HTTP request fails? You will have the office deleted in there, but the office and its schedule will exist in the appointment scheduling. And that's only one scenario. Imagine that kind of failures in multiple scenarios that you have in a system. So what you could do is make as a doctor the HTTP request in the office management, then delete the office from there, and also save in your database an office deleted event which will hold the ID of the office, and that will be an atomic operation. The removal of the office and the insertion of the event will be in the same transaction, and if that succeeds, you would return OK to the doctor, and then asynchronously in the background you would publish that office deleted event with the ID of the office to a message broker, and then you would consume that event in the appointment scheduling service, and you would delete the office and its schedule from that service too. Now you might say, okay, but I have a business rule that says if I delete an office from the office management, I cannot have a delay before it gets deleted from the appointment scheduling. I can accept a delay even of 1 second, let's say. So what you're saying is that the removal of the office and the schedule should be in one atomic operation. Now, if you're starting doing that, and by that I mean a transaction between 2 or more different services, that adds a lot of complexity. It's something that you want to avoid. So if you want that to be an atomic operation, probably you shouldn't have a different appointment service. You would have the office as it was in the office management and the schedule in the same bounded context, and since it's a transactional boundary, it would probably be in the same aggregate as well. And now you could say that, okay, but when I designed the system and I designed that 2 different microservices, I didn't know about that business rule that we can accept a delay of deleting an office and deleting the schedule of the office. Then again, it's bad design. Maybe it's not your fault per se as a developer. You should have asked about if dealing with that asynchronously is acceptable, and maybe it's also a fault from someone else in the team that didn't communicate that requirement from the beginning, but again, it's a design mistake. So that's the main 2 reasons I believe a lot of people talk negative about microservices. So to recap, reason 1 is moving to microservices when you don't need to, you don't have a need, and so you add more complexity without a reason. And number 2, when you design microservices without boundaries, and you have one service directly talk to another, which again adds a lot of complexity and a lot of failure that can happen with that approach. So that was it for this video. If you liked it, please like and subscribe. Thank you for watching and have a nice one.